Good morning, students. Welcome back to 10th Physical Science. In last class, we concluded up to the family of salts. So in this video, we are going to discuss about the chemicals, what we are getting from the sodium chloride, like sodium hydroxide, chlorine, bleaching powder, baking soda, washing soda. Is it clear? So these things we are going to discuss in this video. See, as you know well, from sea we are getting different types of salts. Among that, the most predominant one is sodium chloride. Sodium chloride is the most important salt what we are getting from the seas. So from this sodium chloride we are getting number of chemicals like sodium hydroxide, chlorine, bleaching powder, baking soda and washing soda. See, first of all we will see how one chemical became the main product for all these chemicals. Clear? The first one is sodium hydroxide. Generally, the reaction between sodium hydroxide. How do we get this sodium hydroxide? From this sodium chloride, we will see now. Generally, what is aqueous solution? The chemicals which is dissolved in water is called aqueous solution. Here, this getting of sodium hydroxide is also what we call chloroalkali reaction. What we call chloroalkali reaction, because here the products are chlorine and we are getting alkalis. We are getting alkali. So that what we call as chloroalkali reaction. Chloroalkali reaction. So like that we may get chlorine, hydrogen and the most important product NaOH. NaOH from this sodium chloride. Sodium chloride. Let's see the equation here. NaCl plus H2O will gives NaOH plus Cl2 plus H2O. So these are the products when if you can dissolve sodium chloride in water, nothing but aqueous solution. From that we may get sodium hydroxide, chlorine and hydrogen. The next one is bleaching powder. How do we get bleaching powder? See, the reaction of chlorine on dry slag lime. The reaction of chlorine on dry slag lime will give bleaching powder. See here, Cl2 plus CaOH taken twice will give CaOCl2, calcium oxychloride plus H2O. This is what bleaching powder. Bleaching powder. So the reaction of chlorine on dry slag lime will produce bleaching powder. Even though this reaction is somewhat complex, but we may get this bleaching powder whenever the chlorine is react with a dry slag lime. So as you may know very well, in our day-to-day life, we are using for the different purpose. We are using this bleaching powder for the different purposes, like we are using in the laundry for dry cleaning. And next one, the most one is we are going to use as a oxidizing agent in many chemical industries. We are using this bleaching powder as a oxidizing agent in many chemical industries. The next and the most important one is especially in rainy season, we are using everywhere we are using this bleaching powder. See, to kill the germs or to make the drinking water from free of germs, we are going to use this bleaching powder, because this bleaching powder can kill the germs or bacteria, anything which is present in drinking water. Clear? The next one is, I think all of you know very well about chloroform. Chloroform. So in that chloroform, this bleaching powder is act as a reagent. So they may use as a reagent in the preparation of chloroform. In the preparation of chloroform. This is about bleaching powder. Of course, you know very well. Again, we are getting this bleaching powder from sodium chloride only. Sodium chloride. Is it clear? The next and the most important product what we are getting from this sodium chloride is baking soda. Baking soda. So generally, what is use of this baking soda? Generally, we may use this baking soda for faster cooking. We are using this baking soda for faster cooking. The chemical name of this baking soda is sodium hydrogen carbonate. Sodium hydrogen carbonate. So now we are going to see the preparation of baking soda. So what are the chemicals required for the preparation of baking soda? The first one is sodium chloride NaCl plus H2O plus CO2 plus NH3 ammonia. So then the final products are ammonium chloride NH4Cl plus NaHCO3, sodium hydrogen carbonate, and we may get ammonium chloride as final products in this reaction. So now tell me, can you find the pH value of these sodium hydrogen carbonate? Yes, definitely. So whenever you can test with this pH paper, then definitely we may get the pH value of this baking soda is more than 7. So definitely this baking soda is a basic salt. A basic salt. Why? Because it may act like as a mild non-corrosive base. How does it act? Like as a mild non-corrosive base. So what happens whenever if you heat this baking soda? So whenever if you heat or whenever if you add in at the time of cooking, then this baking soda is splits into Na2CO3 plus H2O. It gives Na2CO3, sodium carbonate. Clear? Now we will see what are the daily life application of this baking soda. Especially, I think all of you know very well, whenever if you touch cake or bread, how do you feel? They are smooth and spongy. The reason is the adding of baking soda at the time of preparation of cake and bread. The next one is the baking soda we are using in antacid tablet as a ingredients, or we are using as ingredients in antacid tablets. So because of its basic nature, it can be neutralize the acid which is present in our stomach. So whenever if you get stomach pain, no, at the time we are going to take this baking soda so as to get relief from this acidity. The next one is we can use this baking soda as soda acid fire extinguisher. We can use it as a soda acid fire extinguishers. And the last one is this baking soda is also act as a mild antiseptic. How does it act? It acts like as a mild antiseptic. So these are the uses of this baking soda. So next coming to this washing soda. Washing soda also what we call sodium carbonate. So how do we get this washing soda? As you know very well, whenever if you heat this baking soda, the product is Na2CO3. The product is Na2CO3. So on heating the baking soda, we can get a washing soda. Otherwise, the recrystallization of sodium carbonate will use washing soda. The recrystallization of sodium carbonate will use washing soda. For example, if you take Na2CO3 plus 10H2O, will gives Na2CO3 10H2O. So this is washing soda. So we can get washing soda by heating baking soda, either baking soda or recrystallization of sodium carbonate. We may get this washing soda. See, this baking soda and washing soda are very useful for the chemical industries. So now we will see what are the uses of the washing soda. So generally we are using this washing soda in glass, soap and paper industry. Next we are going to use this washing soda in the preparation of sodium components such as borax. Next we are going to use as a cleaning agent for the domestic purposes. And the last most important one is by using this washing soda we can remove the permanent hardness of the water. We can remove the permanent hardness of the water. So next one is here I would like to ask one question to you. See, I wrote here Na2CO3 10H2O. What does mean? What is 10H2O? See, whenever if you can absorb the crystals of salts, then they appears as dry, but practically they may contain some water molecules. How do you know this? In order to know this, first of all, we have to conduct an activity. See, if you can take some amount of salt in water, if you can heat, then you could find some water drops on the walls of the tubes. So it clearly shows that the crystals of salts contains water molecules. So now tell me, the crystals of salts dry or wet? Definitely they are wet. Definitely they contains some amount of water, the number of water molecules. So the next one is here we are going to discuss about the plaster of Paris. The plaster of Paris. See, as you know very well, if you can observe the daily life, for example, the doctors, they may use this plaster of Paris to set the fracture bones in right position, and generally you may observe the ceilings in our houses, and to make the toys and for decorations we are going to use this plaster of Paris. Then what is this plaster of Paris? How do we get this? See, before going to see the preparation of plaster of Paris, first of all we have to know about gypsum. Gypsum, the chemical formula of gypsum is CaSO4 2H2O, calcium sulfate hydrate. Calcium sulfate hydrate. Here this calcium sulfate hydrate contains two water molecules. This is nothing but gypsum. See, on careful heating of this gypsum, the gypsums may lose a water molecule and it gives CaSO4 half H2O. This is nothing but a plaster of Paris. CaSO4 half H2O, calcium sulfate hemihydrate. Calcium sulfate hemihydrate, nothing but plaster of Paris. Plaster of Paris. See once you observe here. So whenever if you can heat careful heating on gypsum, it may loses water molecules and it gives calcium sulfate hemihydrate called plaster of Paris. So sir, how the doctors can use this plaster of Paris to set the fracture bones in right position? See, this plaster of Paris is a powder, white powder. Whenever if you mix with water, then it will be turns into a hard solid mass. A hard solid mass. For example, see reaction here, CaSO4 half H2O. When if you add to the water, then one and half, because here one molecule of CaSO4 contains two molecules of water. So that's it can share 1.5 molecules of water and it can forms CaSO4 2H2O. CaSO4 2H2O, gypsum. Clear? See, if you want to get more information about this lesson, you please watch these videos again and again, and you please watch these videos again and again to get more information or the brief explanation about this lesson. Thank you. Thanks for learning.